Let's look at a similar example. Let's ask, what are all the solutions to 2 times cosine squared of theta plus 2 is equal to 5 times cosine of theta? So before we get to this looks a little intimidating, but we need to remember, first of all, that we can use the unit circle to our advantage. So if we have anything with sines or cosines, then we can actually solve using the unit circle. Just like before, we can use periodicity to our advantage to simplify our initial solving and then extend it. And lastly, we can also use algebra to decompose the equation into parts. So let's go to the board and try it out. Okay. So here we have our initial equation, and we'd like to solve it. So what we can do is start thinking about what are the trigonometric functions here. So we have this one, this cosine squared of theta, as well as this cosine of theta. And what we can actually do is, if we think of this as something like a y, as some other variable, this is really just y squared. Cosine squared of theta is just cosine of theta squared. So if we kind of really blur our eyes, we can actually see this as a quadratic. So here we have something squared with a coefficient, something else just by itself with a coefficient, and a constant term. So we really want to treat this like a quadratic expression and then try to factor, for example. So what do? We don't leave it like this. We try to move everything to one side so that we have a 0, and then we factor. So let's move this 5 cosine over. So now we have 2 cosine squared of theta minus 5 cosine of theta plus 2 equals 0. So remember, this is, again, something like a y, and this is something like a y squared. So how are we going to factor this thing? So we have something over here and something over here, and that's all equal to 0. Again, we want 0 on one side because if we factor this apart and 2 things multiply to get 0, one of them has to be 0. So this is breaking our equation down. So since cosine is kind of taking place as our variable, then we're going to have a cosine on both sides, cosine of theta on both sides. And now we have to figure out what the constants are. So since this is a 2, then if this is going to factor with just integers, 2 doesn't break down anymore, so it has to be a 2 and a 1. And since 1 doesn't really do anything, we can just leave that. And now we want to figure out what are the constants that give us these, give us a 2. So we need 2 numbers that multiply to get 2. And when we multiply this far right number with the 2, and we add that to this inside number with this 1, that we get a negative 5. So what numbers multiply to give us 2? Well, it's either 1 and 2 or 1 and 2. And further, they can be, since they're both being positive, they either are both positive or both negative. So let's try the positive. Let's see if that works. Maybe a 2 over here and a 1 over here. So this is just an attempt. Then if we multiply this, we get a 4. And we add this together, we get a positive 5. Well, that's not what we want. We want a negative 5. So what we can do is try switching these up. Let's just make them now both negative. If this works, let's see. Well, we have 2 cosine times negative 2, so that's negative 4 cosines. So that's almost there, plus 1 more negative cosine. So that gives us this value here. And lastly, we also have that negative 1 times negative 2 is positive 2. So therefore, we factor this. If maybe we switch the 2 and the 1, we would see that we're nowhere close, so we would just have to alter it around. And if there was no other option, we could even use the quadratic equation if we wanted. But luckily, this factored out nicely. So what was the advantage to factoring? Now we know that there's 2 conditions that could happen to make this equation equal or satisfied. We either have that 2 cosine of theta minus 1 is equal to 0. Again, because since 2 things are multiplied to get 0, either this one is equal to 0 or this one is equal to 0. So either the left side is equal to 0 or the right side is equal to 0. Okay. So let's keep doing algebra to simplify this so that eventually we can use the unit circle. And let's just start with this right one. So how do we solve for this guy? How do we just get cosine alone? Well, we're going to add 2. Now, if we want to try to solve these solutions, if we want to find when this is satisfied, first of all, our variable is theta. What could it be? Well, actually, if you think about, we're looking for an x value equal to 2. So let's go to the board and see about it, or to the slide. Well, cosine is our x coordinate, so we need x equal to 2. So here is 0, our x value. Here's 1/2, here's 1, and here's 2 over here. Well, the unit circle never hits that. So actually, cosine of theta is never equal to 2. So this has no solutions. But since this can never be equal to 2, it could be that this one is equal to 2. That's our other option. So let's look at this. Let's try to solve it out. So 2 cosine theta minus 1 is equal to 0. So let's use algebra to solve for cosine of theta. So first we add 1. And again, we're not completely done. There's still this 2 on the cosine, so we have to divide by 2. So we have cosine of theta is equal to 1/2. Now let's try to try to find what are the theta values that satisfy this equation, or this equation, which in turn will satisfy this equation. So if we look at the unit circle, again, we're looking for cosine of theta to be equal to 1/2. So here is 0, and here's positive 1/2. So it looks like this point here and this point here are both solutions. So one of those solutions is pi over 3, and look right there, there's cosine of pi over 3 is going to be equal to 1/2. And likewise, cosine of 5 pi over 3 is also going to be equal to 1/2. So those are our 2 solutions from 0 to 2 pi. So we have pi over 3, and what was the other one? It was 5 pi over 3. And lastly, since we're asked for all solutions, and we're talking about cosine, where the periodicity of cosine is 2 pi, all we have to do is add this 2 pi n term like we did before in both spots, where n is an integer. So when is 2 times cosine squared of theta plus 2 equal to 5 times cosine of theta? Only these are solutions. This pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n when n is an integer.